Hello student, my name is Benihard Fraxon Masebo. I'm a senior mathematics teacher holding bachelor degree of education, majoring mathematics from University of Dar es Salaam. As we have been sharing with you with the part of mathematics in particular to advanced level, today we are going to continue with our topic of algebra where we ended the previous session. Welcome. Okay, we saw the concept of algebra where we ended with the part of binomial theorem, which was not concluded. It was just an introduction part of binomial theorem. So far from algebra, we know the idea of exponents, the knowledge of logarithms, the idea of series, and we went with the part of Pascal's triangle, and we saw how Pascal's triangle was a tedious task upon solving and expanding some expressions. And then we went far now, where we saw how binomial is so applicable. Binomial is there to solve and to cut the problem of Pascal's. Okay, so we said, binomial theorem. Binomial theorem. Clearly, when we have x plus y power n using binomial, the expansion of binomial, we said this is the same as writing any combination 0, x power n plus any combination 1, x power n less 1, y power 1, plus we keep on summing up to the end. This gives any combination any, and here we will have x power 0, where then y power n. This expansion of binomial theorem, which can be summarized using the concept of summation symbol, which is called sigma notation, is going to take us with some important identities with binomial. So we say, we know from this one, we say identities for binomial theorem. Identities for binomial theorems takes us from this hint here. We say, we are sure that when is a plus b power n, we have seen this is simple as any combination 0, a power n, any combination 1, a power n less 1, b power 1, any combination 2, a power n less 2, b power 2 plus, and here we are having the last term here, which is going to be any combination n, and here a power n less minus n, which is n power 0 anyway, which is 1, and a number power 0 is 1, and this is b power n. So we say, when 1 is giving us a minus b, what is going to happen here? The expansion on this is just going to switch just from the fact that a negative number with the odd exponent is always negative. It means here it could be any combination 0, a power, and this becoming minus because of this. So upon plugging with this b here, b is negative. So any combination 1, a power n less 1, or b power 1, this one will be becoming positive. Do you know why? This is because when you take negative b square, it's going to become positive. So any combination 2, a power n minus 2, b square, the next term could be becoming minus. So terms could be going, the last year could be depending with any combination any minus any, and negative b power n. So we say this is another identity. So we say, suppose we have some expression taking a plus b power n plus a minus b power n. It means we have summed line 1 and line 2. What is going to happen here, class? You can try to predict. Do you see what is going to happen with the pattern of the series? It is easy to say. This will be summing with this, giving twice any combination is 0, a power n. This term is going to vanish because plus and minus. So summing algebraically, cancellation on this. This is going to exist, giving twice any combination 2, a power n minus 2, b power 2. Next term is going to become what? Twice any combination 4, a power n minus 4, and here b power 4, plus terms could keep on appearing. Again, when we take this a plus b power n, this time take minus a minus b power n. This one also, class. Can you tell us now what is going to happen here? Okay, tell us what is going to happen here, class. It is for sure that you will notice that in the first term are the one which is going to cancel because positive or positive. These are the one which is going to cancel. The second term will be summing algebraically. You know, this minus minus will be becoming positive. Therefore, this is cancelling. We are going to have this one 2, any combination 1, a power n less 1, b power 1, 2, any combination 3, because here is going to vanish. The term which is going to exist is the one which follows here, plus, minus, minus, negative. So, a n minus 3, b power 3, plus, it goes. Now we have 4 identities from this one. So we say, from the first formula here, I could call this is 1, and this is 2, and this is 3, and this is 4. I can call this. Let's call them by equations. So we say, from 1, setting a equals to 1, b equals to x. If we set a is 1 and b equals to x, we will be sure that this formula, what is going to happen? This formula will be changing. Now we say the formula becomes now 1 plus x power n equals to any combination is 0. Mathematically, going from definition, is just going to give us 1. And a, which is 1 now, which is 1 power n, so becoming just strictly 1, plus any combination 1 is giving us any from definition, and a here is the one which takes 1, so 1 power anything is 1. b is 1 is x, any x followed by n minus 1, x square, 2 factorial, plus it goes. The formulas here, which has been listed, this is formula 5, and we can call it 5, equation 5 with this. These formulas are so useful when trying to operate several expressions involving binomial theorem. You can tell me, how are we going to work with these ones? We are now going to the part calling it as the application of binomial theorem. Application with binomial theorem. As we have seen the expression here involving binomial, which are so much explainable just from the identities. We want now to check how can we apply binomial theorem in the real life situation, in particular to mathematics. So we say below are the applications. Below are the applications. 1, we say used for expansion of expressions. Application 1, used for expansion of expression, which we saw the previous time, and here I'll be not taking time upon expanding. When one is giving you like 2x plus y, let's say power 3, using binomial. Count example here quickly. We could just say is 2 power 3, 3 combination 0, 3 combination 1, 2x power 2, because we take 3 minus 1, and this y starts now. Here is 3 combination 2, 2x power 1, and the y starts plus, and the last term here could be y power 3, 3 combination 3. Upon expanding this one, switching then, we could be having this one 3 combination 0 from scientific calculator. Of course, it is known. 3 combination 0 means 3 factorial, 0 factorial, 3 minus 0 factorial. Working on this, giving us what? 1. Similarly, using the same definition, this one now could be giving us 80x power 3, and then use expanding on this part could be giving 3 combination 1, 3, with 2 square is 4, and 3, 12, and here we have x power 2 plus, connected with y is here, and here 3 combination 2 is 3, 2 times 3, 6, we have x y square plus, and there are 3 combination 3 is 1, y power 3. This is the expansion of binomial theorem, one of the applications. Application 2, this one we say, with binomial theorem, with the applications. Application number 2 we say, use D to determine the number of terms in the expansion. Use it to determine the number of terms in the expansion. Here, to determine the number of terms in the expansion is of great importance. It depends with the nature of the expansion from identities. So here we say here it depends with the identity. It depends with the identity to determine the number of terms in the expansion. So we say clearly, starting from there, we say clearly from our part, from 1, the number of terms gives n plus 1 terms. If one says identify the number of terms in the expansion like a plus b power n, it means when you expand, let's say x plus y square, n is 2. You expand here, you get what? X square plus 2xy plus y square. It means 3 number of terms. When the exponent is n, the number of terms is n plus 1. So 1 is giving you 3x plus y power 20. How many number of terms? Upon expanding, n is 20 plus 1. So there exists 21 terms in the expansion. This is a concept how it says. And then from 3, 2 gives nothing. It works the same as 1 to know the number of terms. But the important idea here is for us when we want to know the number of terms in case 3, from 3, number of terms. We say from 3. From 3, the number of terms here, it depends, we say depends with n. Depends with n to know the number of terms from case 3. From case 3, when if n is even, if n is even, then we have n over 2 plus 1 terms in the expansion. When n is even, we have n plus 1 over 2. But if n is odd, number of terms is n plus 1 over 2 terms. You can see how it is very important, class. This is a very tricky concept. A learner needs to be intelligent enough to grasp this idea. It means we say when we expand, we have seen some terms with cancelling with this one. Some terms are cancelling. We have seen step 3, stage 3, question 3, when we were summing this and this. Question 1 and 2, this is summing, this is cancelling, this is summing. So it means there is some cancellation of some terms. So the series is going to be condensed. Some terms is going to vanish. That is why it depends with any now. When n is even, number of terms is the one we are talking here. Number of terms is the expansion of the series is going to become n over 2 plus 1 terms. If n is odd, the same case, equation 3, number of terms becoming n plus 1 over 2 what? Terms. Now from, okay, now let's check. We are going to check now from 4 to see the number of terms, how it works. However, this press is enough. We can make it. Okay, let's look now. Case number 4. Welcome. Okay, so we have seen how can we find the number of terms upon the expansion from the binomial theorem. And now we are going to switch from our portion, where here we say from 4, our equation 4, which was now taking like this. The number of terms here we say, number of terms we say if n is even, number of terms is n over 2 terms. But we say if n is odd, number of terms is n plus 1 over 2 terms. Now this is one of the application of binomial theorem used for identification for the number of terms. So one can give us a question like identify the number of terms in, let's say one can give us A, 2x plus 1 power 4 plus 2x minus 1 power 4. Number of times B, one can give us x squared plus 2x plus 1 power 60. And another question, one can give us a question like x minus y power 9 minus x, this is supposed to be plus, x minus y power 9. Identify the number of terms from expansions like these ones. So here, class, using the formulas we have posted at the top there, it is easy to say, with this one, our n is even. And since n is even, we have seen the number of terms is from our n which is even, number of terms is n over 2 plus 1. It means 4 over 2 plus 1. It means 3 terms in this expansion. With B, one could just say 61 terms, which is not true. What is important, you must check inside, there is 3 terms in the expansion, in the bracketing. Therefore, to know the number of terms here, we must first try to factorize this part. So we say, with B, factorizing the inner part, x squared plus 2x plus 1, but here power 60. Inside here could be giving x plus 1 power 2. But with 60 outside, using the law of indices, 2 and 60 is going to give us x plus 1 power 120. So number of terms what? 121 terms. It means we are taking n plus 1 number of terms. Similarly, could be applying with this case here, where now our n is odd and it is minus. With n odd and with minus, now we are switching to our formula. When n is odd, from case number 4, which is minus, number of terms is what? N is odd, n plus 1 over 2 number of terms in the expansion. So the number of terms becoming what? With C, becoming 9 plus 1 over 2, which is giving what? 5 terms in the expansion. This is one of the most important application of binomial. Another application, which is now 3, we say use it to determine the nth term nth term in the expansion, also called the general formula, used to determine the coefficients in the expansion. You can know the coefficients of a certain term in a given expansion. We can also have the nth term or the rth term. The rth term can be counted from the end or from the beginning of the expansion, and used also to determine the term independent in the expansion. Term independent in the expansion, when one gives x plus maybe 1 over x power n, the general formula of binomial theorem is critically known any combination r, x power n minus r, and here 1 over x power r. So the term independent will always exist when the exponent appearing in this will be the same as. So suppose here could be m, let's say. We use m here. It means the term independent could appear when n minus r equals to rm, solving for r here. It means r coming to the other side, becoming n equals to r take outside 1 plus m. It means we want to know our r. It means our r must be n over 1 plus m, where r must be the set of natural number. What does it signify? When at all given the expansion like this one, upon performing the expansion and the question is asking you to determine the term independent in the expansion, if it happens n is not a natural number upon treating from this formula, then the comment will be there exists no term independent of x in the expansion. That could be the conclusion. I'm saying again, when r is not a natural number, upon treating from this our formula here, then the conclusion will be there exists no independent term in the expansion. Although the question is asking you find the term independent of x in the expansion, but treating by the formula and the necessary condition for r is supposed to be a natural number. Okay, this is one of the application. Another application, we say use it to determine the greatest term in the expansion. Greatest term and the greatest coefficient in the expansion. Now I'm going to pose you with 3 questions which will be involving these applications, and you'll be so much impressed with this part. Welcome. Let's go together. Okay, student, we have seen the application of binomial with the parts here, which we wrote here. 3, we said, use it to determine the nth term, the coefficient in the expansion, the term independent, and the greatest term in the expansion. Term independent, we have seen the rule, how it works, the formula finding the term independent. And the greatest term in the expansion, we can also have to know the concept used to determining the greatest coefficient in the expansion. So we say, all the listed there are the applications of binomial theorem with their counter examples, which I'm going to post to you. For sure you are going to be so much interested to see, and we are going to experience how it is good to know the knowledge of binomial theorem. So to begin with here, let's go direct with the part of worked examples. Worked examples. So here to start with, 1, we say, use binomial theorem to find the nth term, to find the nth term in 2x plus 3y power 7. To find the fourth, I can say the 14th term in A above. 14th term in A above. And here we can say to find the coefficient of x power 39 in A above. Checking carefully, you will notice that in parts A, B, and C are all a result just depending with A. Now let's also check to treat this question. We will just say solution. Solution here we say clearly from the trick we know A plus B power n equals to any combination R, A power n minus R, B power R, which is the general formula for the expansion of binomial theorem. In the same way, so here we say thus, with our A now, finding the nth term in this expansion, it means taking 2x plus 3y power 70. We will just take 70 combination R, and we will take 2x power 70 minus R. Our B is 3y. This is power R. This is a general formula. This is the nth term in this expansion. However, one could go upon simplifying, but no need of wasting your time. Just take, this is a general formula in the expansion of our binomial theorem. Now using result in A, treating for B. B says what? Find the 14th term in A above. 14th term in the binomial expansion. The 14th term, we have seen the first term is always combination 0. The second term combination 1. It means when we are treating the 14th term, it means we say 14th term means R becoming 13. Because first term is combination 0. Second term, so when I'm taking the 20th term, a combination must be below by 1, less by 1. Therefore, I'll be just taking it 13. It means here becoming what? 70 combination 13 and 2x power 70 minus the 13, 3y power 13. This is the 14th term. Of course, we could be treating this and then simplifying this one. It could be giving us 70 now. We have seen how it works there. And then from there now, to take now the result, you must have to know the coefficients and the result. How do we proceed there? We simply say 70 combination 13, 70 combination 13, 70 minus 13, this is giving what? 57. So 2x power 57. And here 3y power 13. Now this is simply the 14th term is expansion. C says what? Find the coefficient of x power 39 in A. The coefficient of x power 39 in A, maybe to make it simple, I could say in B. Yes, let's continue. Let's continue because it becomes another new question we will treat us. Find the coefficient of x power 39 in A. It means here we say, we know the general formula, which is 70 combination R, 2x power 70 minus R, and here now 3y power R. So to know the term which would be the coefficient of x power 39, it means we must treat, we say here, solve 70 minus r equals to 39. It means you want to know the exponent of x to become 39. So what is becoming? R will become 70 minus this. Is this 31? Yes. It means it will be becoming 70 combination 31 to x. So this is giving 39 here, 3y, and here is 31. Arranging this will give 70 combination 31 2 power 39 times 3 power 31 times x power 39 and y power 31. Now the coefficient, this is the required coefficient as per our problem. Of course, you could be trying to find the result on this using our non-programmable scientific calculator. However, is meaningless. You know why? Because this becomes numerically very large number. We better express it in that technique of exponents, indices we mean, and where the number is really manageable enough. Okay, let's look example 2. Example 2, this now is involving, we want to know, at least here we have gone through the nth term, the coefficients. Now let's look the term independent in the expansion. Term independent. One say find the term independent of x in, I have a nice question here, in x plus 1 over x, let's say power 2, brackets, power 14. The term independent from our formula, which is this one, it means here we could just write like this. Solution. One could be just taking 14 combination 0, combination error, we mean 14 combination error, x power 14 minus r, 1 over x square power r. Now, to know the term independent, it means 14 minus r, which is this one, must be equal to 2 and r, which is 2r. Correcting like terms together, it means 3r equals to 14, and our r becomes 14 over 3. This number here is not a natural number. And since it is not a natural number, the conclusion here we say what? There exists no term independent of x. We said the necessary condition, a term independent of x will exist only if n is a natural number. Okay. Now, I could be finishing with one example and then we could be going for a short break. Okay. So with that concept now, one is giving us now another, this question says find the term independent, find the term independent of x in, let's say we have x square minus 1 over 2x, we can have power 24, let's say. In this problem class, it is interesting to check this. What is important? You must first refer to our general formula of binomial. So here we could say solution here. First of all, we say 24 combination r, x square, and here outside 24 minus r times negative 1 over 2x power r. To find the term independent, we will be taking this exponent here. So here we say, how do we get the term independent in this part here? We say, let's take this setting here, setting 2, 24 minus r equals to r. It means this is power. Avoiding brackets here, 48 minus 2r equals to 2r. Collecting like term 3r equals to 48. So it means here what are you giving 16? 16 is the set of natural number. So if that is the case, it means they exist the term independent. When r is 16, it means this is the 17 what? Term. So term independent occurs when r is 16. So this becomes what? 24 combination is 16. And here we have x square, and here 24 minus 16 times negative 1 over 2x, but here power 16. Treating this one, it will be all giving 16 in all cases. So you have 24 combination 16 here, combination 16. This is going to give us 16 here, times negative 1 over 2 power 16 times 1 over x power 16, where this one cancels on this, and therefore have the term independent, which is 24 combination 16 times negative 1 over 2 power 16, which is easy to conclude. And then I could be finishing with the last example. This is another one. One can say, find the 14th term from the end. From the end. In let's say x plus 4 power 7. This is really a very, very nice example. Find the 14th term from the end. It means one could be counting exhaustively, starting from the first term, expanding this one, starting with 70 combination 0, up to the end, and then count from the end, 1, 2, until you get the 14th term. That task is possible, but is really too mechanical and wastage of time. Therefore, to solve this question, you must go with this trick here. We say, to solve that question, you must take this trick here. We say, clearly, the R stem from end, this was from end, is the same as any minus 2 minus plus 2 minus r term from the beginning. From the beginning. It means it's very difficult to analyze the terms mechanically, finding the 14th term from the end. Instead, you must know. If one says 14th term from the end, you must know 14th term from the end is the same as which term from the beginning. So from the beginning is going to be 70 plus 2 minus 14, which is going to give us 72 minus 14 equals to 72 minus 14. I'm not teaching how to subtract here. Giving 8, 60, 58 is the same as 58 term from the beginning. From the beginning is the same as from the beginning. Therefore, 58 term from the beginning is the same as what? Is the same as the 70 combination 57. It is always less than the term by 1. And where 1 here is going just to say x power 70 minus 58 times 4 power 58, which is a result, and it is easy to know. Okay. Student, thank you for watching. We will be taking a short break, but before we go, next time you will be interested to ask a question. We have a telephone number which you can send your question through WhatsApp, only through WhatsApp, or you can use messaging. You can give an SMS of your question, or you can bring a video of your question through this number, which I'm going to pause here. And this is 07, this is our telephone number, 0769 and we have 048. Again, we have 594. So this number is the one which will be so useful by WhatsApp if you bring a question by WhatsApp, or you bring an SMS, or you can give a video. You can give a video from this. Thank you for watching. We are taking a short break. We will be right back. Don't go away.